A microcontroller is a small computer and a single integrated circuit IC that is designed to control a specific devices or systems. In this video, I aim to provide a brief background on microcontrollers in general and then focus in more detail on the basics of the Redboard Artemis Nano, including how to install its library to Arduino software IDE, and finally the LED blink example. Microcontrollers are used in a wide range of electronic devices in different applications. They have capability to be programmed for performing very specific tasks. A microcontroller can be seen as a small computer, and it contains the essential components inside a computer, such as a central processing unit, CPU, memory, and input-output I/O interfaces, all on a single chip. As this diagram shows the main components of the microcontroller. Let's dive into some common features of microcontrollers. Microcontrollers are designed to operate with low power consumption. This is ideal choice for battery powered devices. Microcontrollers can respond to real-time interrupts, events, and has great capability to operate in real-time environments. They often have built-in interfaces such as analog to digital converters, digital to analog converters, timers, and serial communication interfaces. And the other important feature is that microcontrollers are small and compact, suitable to be used in applications with limited space. Let's talk about designing a simple hardware and software system to see how to use microcontrollers. Circuit design is a crucial part of microcontroller development because the design by itself determines how the microcontroller interacts with the real world. The design process includes selecting the appropriate components and the microcontroller by itself, depending on the project, then connecting them together, and properly interfacing components with the microcontroller through a correct and consistent cabling. This all need to be tested and debugged at the end. After this step, it's time for the software activities. Programming a microcontroller involves writing code in a programming language such as C, C++, MicroPython, or assembly, and then compiling that code into machine code that the microcontroller can understand. The compiled code is then loaded onto the microcontroller using a programming tool such as a programmer or bootloader. I focus on Sparkfun Redboard Artemis Nano, which is a small and powerful microcontroller board that is designed for a variety of applications. It is based on the Artemis module, which is built around the Apollo 3 microcontroller from Micro. The Artemis module used in the Redboard Artemis Nano is designed for low power consumption. It also includes advanced features such as secure boot loader, hardware cryptography, acceleration, and a real-time clock. Here I give a list of features. For example, GPIO, which stands for General Purpose Input-Output, that are pins with capability to be configured to serve as either digital inputs or outputs. They allow the microcontroller to interact with the external world by sending and receiving digital signals. UART here stands for Universal Asynchronous Receiver Transmitter. It is a type of communication protocol used to transmit and receive serial data between a microcontroller and other devices such as external sensors. This is the schematic of the Sparkfun Redboard Artemis Nano that its reading can seem intimidating at first, but with some practice and help, it can become easier. Here are some clarifications might help you to read the schematic, which of course requires some practice and familiarity with electronic components and circuits. The quick connector is a type of I2C compatible connector used in Sparkfun electronics products. It consists of 4 pins with power, ground, and 2 I2C communication lines. I should note that I2C stands for Inter-Integrated Circuit, and it is a common protocol used in microcontroller-based projects to connect to a wide range of devices. The I2C pins on the Sparkfun Redboard Artemis Nano are located on the board's edge at different places. Specifically, you can see the ones I labeled as SDA4 and SCL4 on the board and are located at D9 and D10 pins. By these labels, you would be able to track different pins from the schematic. For example, a 9 here refers to D9, which has explanation like SCL4, SCK4, TX1, as seen here. Now I'm planning to show how to use the Artemis Nano in a laptop or computer. We need to install the Arduino software IDE, which stands for the Arduino Integrated Development Environment. IDE contains, for example, a text editor, as seen here, for writing code, a text console, and a set of menus. This software connects to the Arduino related hardware, in our case Sparkfun, to upload programs. We need to introduce our hardware and its libraries to the Arduino software IDE first. I listed here few steps in details which are applicable for any type of hardware. First, we need to install and then open the IDE and then install a Sparkfun product by opening the setting menu from the toolbar as shown here. In the opened window, we then copy the link of Upload 3 package into additional board manager URL and press OK. Next step is to install the new package by opening the board manager window that is located in Tools, Board. We search for Apollo and we'll find the package as shown here. Press the install button. After a few minutes, you get the Apollo 3 libraries installed and ready to be used. In this step, all softwares required to use the Artemis with Arduino and along with several examples are installed. We are now ready to use our first example. Most Arduino have an onboard LED and we can control this LED. For that, we need to perform following steps. In general, you can use all examples using following steps. Connect the Redboard Artemis Nano to the laptop through USB socket here. Select your board from the board manager pull down. Select the correct USB port of your laptop. Load the Blink example by clicking this example from File Examples, Basics, Blink. You then observe following example program. In this program, setup function is called once when the program starts up and it sets pin 13 as an output. The loop function is then called iteratively and it turns the LED on and off with a 1 second delay.